Okay. If you pay attention, this won't be too bad. You just kind of one of those deals where you're going to have to. The thing about Chapter 8 and why everybody thinks it's so hard is because just about all the math you do anymore builds on itself, doesn't it? I mean, it seems like most of the section you've done before with a new twist. And that's a lot of part of why some people have problems with geometry is a lot of it is new. The stuff you're going to do, and we're basically doing trigonometry in this chapter that we won't in this section, but we're basically doing trig and some of the others. So it's new. So it's something new. So you're going to have to put the time in to learn the vocabulary, to learn the words, to understand what they mean when they're saying things. For instance, geometric mean. Geometric mean is when you have a proportion like this, okay? The thing that's in here twice, x and x, these are your means. Here and there. These here, A and B, they are called extremes. It's kind of hard to read. Okay, means and extremes. This proportion right here is going to be the basis of everything we do. X here is your geometric mean. So what we're going to do, we're going to solve for x. What's going to happen? X times x is going to give me what? Equal to what? A times B. Everybody okay with that? Does that make sense? Now, to solve for A, or X, what am I going to need to do? Take the square root of both sides. So it turns out X is equal to the square root of AB, or A times B. This is how you find the geometric mean of two numbers, A and B. If X was your geometric mean, this is how you find the geometric mean of two numbers. Any questions there? So I'm going to ask you to find the geometric mean of ... One, I'd like you to do it for 4 and 5. And then I'd like you to do it for 9 and 4. Do that right quick for me. I just want you to find the geometric mean of 4 and 5 and 9 and 4. And I said this is how you find the geometric mean of two numbers, is how I said up there. Everybody about done? What'd you get for the first one? Huh? Probably stopped at square root of 20, didn't you? To find the geometric mean of 4 and 5, you take the square root of 4 times 5. However, when you get to square root of 20, why do you think we did simplifying square roots at the first of the semester? Because we were probably going to do what? Expect you to leave your answers in the simplest radical form. So, simplifying square root of 4 times 5, it'd be what? 2 square roots of 5. Everybody see how I got that? What are we going to do for the next one? It'd be the exact same thing, except we're going to do what? Geometric mean is going to be the square root of 9 times 4. What is that? Square root of what? What the geometric mean of that is what? Any questions there? Let's get that written down. Any questions? Okay. Now, first thing I'm going to do is I'm going to draw a right triangle. Everybody look up here. I'll let you write this down in just a second. I want you to see me explain this. When you have a means and extreme situation, a geometric mean situation with a triangle, it's when you have a right triangle drawn. And then with that right triangle, I draw an altitude from the right angle of the big triangle. Now what happens here is 3 similar triangles are created. The book will ask you to do this. So let's say I labeled this A, B, C, and D. The book is going to ask you to write the similarity statements for those 3 triangles. Do you guys see the 3 triangles? There is the large triangle, the original, and then the 2 created when I drew the altitude. Like I said, don't write, just listen. Now, let's write a similarity statement. So what I'm saying is all 3 of these triangles are similar, but what makes this kind of hard is, what have I noticed about the 3 triangles created? They're all shaped and facing different ways, aren't they? Okay, here's what you do. Start with the big one, triangle A, B, C. Think about where you came from. Is this probably the smaller or the bigger angle of the 2 smaller angles? You know, there's the right angle and there's the 2 other angles. Do you think A is the smaller or the bigger? Okay, so I went from the start of the smallest one, then went to the what? Right angle, then went to the bigger one, right? So, if I'm going to write this in corresponding order, first let's start on the one on its side. I went from the smaller, then I went to what? So I'm talking about this triangle, right?
So ADB.
ADB, because I went from the smaller to the what? Right angle to the what? Bigger. Does that make sense? Well, there's another triangle similar to triangle ABC, and that's triangle what? This one right here, but I got to make sure I write it in the corresponding order, correct?
BDC.
Well, I went from smaller to right angle to bigger. So which one's the smallest, B or C? B. So I'd start at B corresponds to A in this case. D, C. And the reason this gets confusing is When I'm talking about B in this triangle, I'm talking about this whole right angle here, aren't I? But when I talk about B as a vertex in this triangle, I'm talking about this smaller side angle, aren't I? See how the semantics of it can get confusing? Okay, last one is I need to compare the two smaller. The two smallers are so triangle, I'm going to say ADB is similar to triangle, smaller to what? Right to there. What's the smaller? It'd be the same at BDC, wouldn't it? Aren't those your three similar triangles? Obviously, this is a right angle right here too, isn't it? Okay, write that down. Has everybody about got that written down? We're getting close. Any questions on that? We okay so far? Has everybody got that written down? I asked you earlier, nobody said anything.
Yes.
Are we good? Okay. I'm going to talk about three situations with means and extremes. Don't write anything. I want you to listen right now. All three of these situations are going to deal with the same proportion, the means and the what? Extremes. Okay, when you have this situation, there are three means that are created. I don't know what we're watching on that phone, but I'd like it put up, please. Are your headphones in your ear? Huh? Get them out of your ear. Now, we're going to have three situations. The first situation is when we make the altitude your mean. When the altitude, don't write, just watch. When the altitude is your mean, your extremes are the two parts that the altitude made, A and B. So when you can create, there's your extremes, there's your mean. Okay? Your mean is the one that's here what? How many times? Then your extremes are the two parts. So when you make your mean the altitude, your extremes are the pieces created by the altitude, right? This piece on the left and the piece on the what? Right. Everybody okay there? However, you can make three different sides in this triangle your mean. You can make the altitude your mean, or you can make the legs of the larger triangle your mean. What are the legs of the larger triangle? The legs of the biggest triangle here, right? That would be the leg on this side, which we'll call X. And like I said, in this case, that's your what? Your means. Well, when this is the case, your extremes are the piece on that side, which would be this piece from here to here, right? And the whole thing. That's how that works. So when your mean is the leg, it's the piece on that side and the what? So going down to here, what's the other leg we have? I did the leg on the left, now I need the leg on the what? When the leg is your mean, it's the piece on that side, which becomes my what? A, and the what? The whole thing B. And in every single case, this proportion works. The question is, you say to yourself, and how we're going to do a problem when we do this problem is, okay, which one do you want to make your mean? In this case, we made our mean the what? Tell me. In this case, which one's our mean? The altitude of the triangle, right? So the extremes are here and here. In this case, what did I make my mean? The leg on the left side. So what were my extremes? The piece on that side and the what? On this one, which did I make my mean? The leg on the right. So my extremes were the piece on that side and the what? Whole thing. Write that down. Then get your red books out and we'll do some examples. You don't necessarily have to rewrite that proportion as long as you realize that that proportion deals with what? All three of them. It's just, so the proportion stays the same, just what changes? What you make your what? Mean, and as a result, your extremes change. So where would, if you were doing one of these problems, you'd always figure out which one is going to be your what? Because depending on which one's your mean, will depend on what goes in for A and B, right? Isn't that what changes? Everybody got that down? Okay, you got your red books out? All right. Let's look at number 11. All right, looking at number 11. Is this a means and extreme problem? Yes. Because guess what? You have a right triangle drawn, and then you have an altitude coming from what? The right triangle, don't you? So it's a means and extreme. It's like these three we have over here to the left, right? When doing these problems, biggest thing is which one do you want to make your mean? There's no wrong answer here. What are the possibilities? You could make this your mean, because you can make the what? And look at your examples over here. Which ones were x? The altitude on the top here, correct? And then what? The leg on the left and the leg on the right. So I could either make x, z, or y my mean. It doesn't matter. You're going to have to find all three of them. So where do you want to start? Which one do you want to make your mean? The altitude? You tell me what? Z? So you guys want to make this your mean right now. So which theorem over here, or which one? Is this like 1, 2, or 3 to the left here? Like 1. So when this is your mean, all you gotta do is come over here right now, go Z, Z. Guys, watch, I'll leave it up here for you to write. Watch. Z, Z, right? Because that's all, your mean's always the one that goes in there twice. Well, what are my extremes that go with that? Well, if you look over here, when you make your altitude your mean, like on number 1, what are your extremes? The two pieces created, 3 and 9. Now, is that hard of a proportion to solve now? Just knowing the rules, setting it up, is what can be tricky. You're going to have to get to a point where you recognize, okay, I've got a means and extremes problem. I remember Coach drawing the right triangle, then an altitude coming from the right angle. Then you know you have means and extremes. So z times z is what? 3 times 9? 27, right? Then what am I going to do? Take the what? Both sides. 3 square roots of 3 is what you get as an answer. Because square root of 9 times square root of 3. So I found z, didn't I? Okay, I've done that. Now what's left to find? X or? So which one do you want to find? Okay, we'll find this one next. Well, when I make x my mean, or that one my mean, x, x, what are the extremes that go with the mean? Which situation do I have here? 1, 2, or 3? It's kind of 2, but I see what he's saying. He's thinking shorter or longer, aren't you? Whichever way, 2 and 3 are in essence the same thing, aren't they? It's just whether you're doing the leg on the left or the leg on the right, right? And I like to think of it like that because that helps me tell me which ones my extremes are. If I'm talking about the leg on the left, then one of my extremes are the piece on the what? Left, which would be what? And then the what? The whole thing, which is 12. 3 plus 9. Everyone agree? So now I get x squared is equal to what? 36. Take square root of both sides. X is equal to what? It's not too bad, is it? So I found x now. Got one more to find. What is it? When I make that my mean. Why? Why? What are my extremes? The piece on that side, which is what? 9. And the whole thing, stop writing and please listen. The piece on that side, and then the whole thing is what? So what am I going to do now? Y squared is equal to what? 108. Take square root of both sides, y is equal to, well, that's square root of 36 times square root of 3, so that's 6 square roots of 3. Why do you think I had you guys learn how to simplify radicals? Because maybe we might be doing it a little bit later.
Wait, so how'd you get a different number for the second one and then the third one?
Because I have a different means and a different extreme.
Oh,
This-
okay, I see now.
You see what I'm saying?
Yeah.
That in the first one, I made my mean the one on the left. On the second one, I made my mean the leg on the right. We're gonna do number 14, and then we'll be done. Just tell me when everybody's got this written down. I'm gonna try to do this one on the board. Cody, get this written down. Now granted, you can go home and watch the video of this, but at the same time, you guys still need to, it's easier, you can't ask the computer monitor a question. You can't ask me right now a question, so that's why I like for you guys still, even though you can go watch this again, to watch what I am doing, so you can say, like what Tiffany just did. Now, why weren't these the same? That's because she was paying attention and listening, and that helped her. You can't ask the computer monitor that question. Now, it does help you to figure it out on your own, don't get me wrong, but at the same time, and you can press rewind on the computer monitor, so there is help there, but wish I'd have had something like this when I was in school. Would have really helped me in college, especially to be able to go see the professor's lecture again when you go home. All right, everybody got this down? We good? Okay. Wow, I forget that it zooms so much more on the screen on my computer screen than it does there. I really don't even want it that big. Okay. Okay.
Ooh, I like this.
Now, what are we going to do here? We've got the same situation, do we not?
Yep.
Here's what's different. Your variables aren't all the means, are they? It doesn't matter. What you'll find lots of times is that it's hard to, you won't, and especially the first time you do one like this, you're not going to see where you're going to have one variable right off the bat. So the best thing to do here is do all three situations. First of all, which one do you want to make your mean first? 5? Okay. We'll do this one first. So what goes here? Huh? What goes here? Good. Now, which situation do I have here? 1, 2, or 3? 1. So what are the extremes? the pieces, x and what? 2. Easy peasy, right? Okay. Let's make another one. Now, because you're going to have to use all three, aren't you? We're going to make all three before we solve it. Which one do you want to make your, what other one can be your mean now? Y? Okay, we'll do y now. So what does that mean? That means when I make this, what's going to be here? Y, and what's here? Now what's here? Well, when you do the leg, it's always the piece on that side. What's the piece on that side? And then the what? The whole thing. Now, people have problems with this. You guys had no problem on the other problem where it was 9 and 3, did you? We had no problem seeing that it was 9 plus 3, right? Is this any different? No. It's just that I don't know what x is, so I can't tell you exactly what number is, but this whole thing is going to be this piece plus what? So what goes here? Everybody okay there? See where I'm getting at? Okay. Last one. Which other one can I make my mean?
C.
Well, what are my extremes then? The piece on what? That side, which is what? And the whole thing, which is? See, as you can see, depending on where you start, and I'm going to go ahead and label this thing, the whole thing here is what? Depending on where you start, turns out we got lucky and picked the right place to start, didn't we? But if you had decided, okay, I'm going to make z the mean, would you be able to find z right off the bat? Why not? Because I have z's and what in this equation? X's. Okay, I can't solve and find both of them. A number of these. I could solve for z, but that's going to be a big mess. I wouldn't mess with it yet until you have to. Right here, if I tried to find y, could I find y?
No.
No, because I have y's and what? Now I could do two equations, two unknowns, but they're different two equations, so that wouldn't work. Here, how many unknowns are here? Just one. Right, Morgan? So, can I find x? You like?
That's me.
Oh, I know that's you. Cross multiply, what do you get here? X times, how about we go 2x is equal to, what's 5 times 5?
21.
Very good. Or 5 squared. Everybody see what we got there? Divide both sides by 2. What do you get? I'm going to allow you guys to put, when it rounds to equal like to 12.5, it's okay to do that there when you're dealing with this kind of problem. Because to be honest with you, I don't want you guys to have to deal with 25 over 2 when you put it back over here. So it's okay to use decimal there. It's just when you get left with a square root and no decimal in it, I want you to simplify that square root, okay? When you leave an answer without a decimal in it and a square root, I want you to simplify the square root. Okay? Does everybody see how we got that? Now, how does that change everything over here? I can plug it in, can I? Now x is what? 12.5, and now this is what? 14.5, isn't it? Yes?
Wouldn't it be the square root of 25?
No.
Actually. Why?
When did I get an x squared? Do you see an x squared there? You just got used to using a square root in the other problems. And just kind of assume that you're always going to have a square root, right?
Yeah.
And that's not necessarily the case. That's important. Every situation is different. In this situation, I went 5 times 5, which is 25, right? I didn't go x times x, right? You see the difference now?
Yeah.
Good question. Okay.
You only do it when there's a square.
Yeah, we're doing it as a result of having y squared, x squared. That's when we take square root of both sides, and that's not going to happen every time. So now let's adjust this equation now by plugging x in. What would it change to? It'd be 2 over y stays the same. Y would still be on top. What does the bottom become? 14.5. Do you guys agree? Is everybody okay with that? Now what do I do? Cross multiply. multiply and solve, so I would have y squared is equal to, what is 2 times 14.5? 29. How would I solve that? Now, because I have a y squared, I take the what of both sides? Very good. And you don't have a decimal under the square root, so just leave it as a simplified square root. So it'd be square root of 29. So you guys can get started. Everybody stop writing and listen and watch me do the next one, then you can write it down. Okay, the next one. How would this change?
2x.
This becomes, what does this become right here? X. 12 point what? Over what? Z over what does this become? 14.5, correct? So I have z squared, and I'm going to need you here, is equal to, someone tell me what 12.5 times 14.5 is. I don't have that one memorized. And I'd rather not do it in my head.
181.25.
Huh?
181.25.
181.25. Now, am I done? I need to take square root of both sides, don't I? So z is equal to, now, you have a decimal under the square root. Now round your decimal to the nearest tenth or hundredth, and you can use the button on your calculator. See here, no decimal underneath. Let's just leave it as that. Here with a decimal, I'm not going to ask you to simplify that square root. Let's just see what the square root of 181.25. 0.25 is in our calculator. What do you get? Z is approximately, round it to the nearest tenth. 13 point what? There you go. Your assignment. Numbers 1 through 6, 8 through 23. As always, write the problems, draw the figures, show all steps and work, prove to me that you are doing the work. Grade and correct, because what is homework? It is practice. You're not supposed to know how to do it perfectly and correctly every single time when you just started. Okay? So, prove to me you were trying to work. And when you grade it, just mark it wrong and off to the side do your, I'd like to see how you made a mistake. It's okay. Mistakes are a good thing. You can't make mistakes if you don't try.
You know the square root button, I don't have.
You gotta turn it sideways.
I don't know.
Okay.
It says square root of x, I think, doesn't it?
It says x over 2 times. Psychology.
Oh,
It's
Mm-hmm.
oh, the other ones are